Welcome back to the next part. Here we're gonna discuss more and more examples that about the balancing of a redox reaction. Okay, so moving to the next example, that is potassium permanganate, which titrated against oxalic acid or simply oxalate C2O4 minus in acidic medium. So MnO4 minus become Mn2 plus and C2O4 become CO2. Ready? Fine. So this is a skeleton reaction. So let me balance that. So I'm showing it once again. MnO4 minus plus C2O4 minus gives Mn2 plus CO2. What about our first step? Check the oxidation state of all elements. So here manganese is in +7, here carbonate is in +3, here manganese +2, the carbon +4, right? So identify the elements with the change in oxidation state. The first one is manganese. Element with the change in oxidation state. The first one is manganese. And manganese having reduction. And the second one is carbon. And carbon having oxidation, right? Yes. Manganese having reduction and carbon having oxidation. So make their numbers same. Here one manganese, here one manganese. That is okay. Here 2 carbon. So you have to multiply 2 here. Ready? Fine. Then make electron lost and balanced same. So electron lost in manganese, gained by manganese. Change in oxidation state from 7 to 2, that is 5, into number of manganese 1. So 5 is the change in oxidation state. Or electron gained. What about electron lost? Change in oxidation state from 2 to, it is from 2 to +3 to +4, that is a change in oxidation state 1 unit, into number of carbon, that is 2. Change in oxidation state from +3 to +4, that is 1 unit, and the number of such carbons are 2. So the total is 2. So 2 electron lost, 5 electrons gained. So you multiply here with 2 and here with 5. Right? Then only these two become 10. So manganese part by 2. Carbon part by 5. Here 5. When you multiply 5 here, it become 10, okay? It become 10, fine. So electron lost and gained is over. Check the ionic charge. 2 into -1, -2. 5 into -2, that is -10. Ready? 5 into -2, that is -10. Is it okay? So the total negative charge is -12 here, right? Yes. What about here? 2 into +2, that is +4. 5 in or 10 into 0. This is 10, right? Yeah, 10 CO2. 10 into 0. The whole charge of CO2 is 0. This +4 is given by me. Okay. So 10 into 0, that is 0. So here 4 positive charge and here my 12 negative charge. Whatever it may be. To balance the excess charge, simply check the medium. Medium is acidic. Okay. So simply supply 16H plus to here. Then what happens? Here will be -12 plus 16. What will be the answer? +4. Okay. So here from in the left side it will be +4. Right side is already +4. So you should add 16H plus here. So 16H plus is applied. So there is no other hydrogen here, right? Yeah. So 16H plus, in the opposite side it become 8H2O. 8H2O. Is it okay? Okay. Moving to the next. 8H2O, simply you confirm. You confirm the case. 2 into 4, 8. 5 into 4, 20. So left side having 20 oxygen. 28 oxygen. What about the right side? 10. This is 10. 10 into 2, 20. Plus 8, 28. So this reaction is balanced, okay? And this reaction is somewhat important. And usually the coefficients are asked in examinations. So simply, you by heart the coefficients, okay? That is 2MnO4 minus plus 5C2O42 minus plus 16H plus gives 2Mn2 plus 10CO2 plus 8H2. Okay, so you should by heart these coefficients. It is frequently asked in questions. Okay, ready. Potassium permanganate and oxalic acid titration. Okay, moving to the next. If dichromate oxidizes sulfite to sulfate, then the dichromate itself reduced to Cr3 plus, right? Yes. What about the case? What about the case here? Listen. So I'm writing the equation once again. Cr2O7 2 minus plus SO3 2 minus. And you know, dichromate reaction should be in acidic medium. And it becomes Cr3 plus plus SO4 2 minus. Okay, fine. So the oxidation states here plus 6. Here plus 4. Here already plus 3. Here plus 6. So sulfur undergoes oxidation and chromium undergoes reduction. Then reduction for chromium and oxidation for sulfur. Make their numbers same. Chromium 2 here, but there is only 1. So you multiply here with 2. Sulfur plus 1 sulfur is there. So 1 sulfur is also there also. Okay. So what about the case? So sulfur is already, numbers are already same. Okay. Then find the number of electron gained and lost. Gained electrons, you obtain the change in oxidation state plus 6 to plus 3 into number of atoms, that is 2. So gained electron is 6. What about the lost one? Plus 4 to plus 6. Plus 4 to plus 6. So plus 4 to plus 6, it is 2 into number of electron lost 1. So it will be 2. So you multiply here with the 2, 3. So here 3, here also 3. Then the charge minus 2. The minus 6. Minus 2, minus 6. Right. So it will be minus 8 here. What about here? Plus 6. 3 into minus 2, minus 6. So here 0. So here minus 8, there's 0. Okay. So medium is acidic. So supply 8H plus here. Then only both sides will be 0. So that 8H plus enters to here, to the left side. And there is no hydrogen other than H plus. So here we have to supply 4H2. The reaction is balanced. What about the oxygen? 7 oxygen, 9 oxygen. That will be 16. 3 into 4, 12. Then 4, 16. So total of 16 oxygen in both sides. Now the reaction is balanced. Okay. Moving to one more case. Action of permanganate in with the iodide in acidic medium. So MnO4 minus become MnO or Mn2 plus, and iodide become iodine I2. Iodide become iodine I2. What about the first step? Check the oxidation state of whole. Plus 7, minus 1, plus 2, 0. So the change in oxidation state is for manganese and iodine. Let's check their numbers are same. Yeah, one manganese, one manganese. Manganese is okay. One iodine, there are two iodine. So you multiply or you start with 2 here. Okay, then find the number of electron gained by manganese. Plus 7 to plus 2, that is 5 electron gained for one atom. Into number of atoms is 1. So 5 electron totally gained. Minus 1 to 0. So for one atom, it lost 1 electron. But number of such atoms are 2. So here is 2. Ready? Here is 2. So 5 electron gained, 2 electron lost. So you multiply here with 2 and multiply here with 5. So 2, 2. So here 5, here 5. So it is okay. What about the ionic charge? 2 into minus 2, minus 2. This is 10 actually, right? Yeah, 10 into minus 1, minus 10. So here minus 12. Okay. What about here? MnO, the total charge is 0. I2, the total charge is 0. So here simply 0. There we have minus 12. And the medium is acidic. So supply 12H plus here. 12H plus. So here 12H plus. Ready? Then the opposite side there will be a 6H2O, right? Yeah. Then finally you count the oxygen. Here 8 oxygen. Here 2, 6, 8 oxygen. Now the reaction is balanced. Okay. Let's check the next case. That is the case of thiosulfate. And your thiosulfate is 2O3, 2 minus in iodometric titration like that. Along with the iodide, it oxidizes. With the iodine. Thiosulfate is a reducing agent and iodine is an oxidizing agent. Thiosulfate with iodine forms tetrathionate plus iodide. Now we want to balance this one. Okay, fine. Finally, simply check the oxidation state. Here plus 2. Here 0. Here plus 2.5. Here minus 1. Ready? Is it okay? Yeah. Listen. Find the change in oxidation state. Find the elements of the change in oxidation state. Sulfur and iodine. Make their numbers same. Here 2 sulfur, there's 4 sulfur. So you multiply here 2. Ready? Multiply here 2. So here 2 iodine, there 1 iodine. Multiply here 2. Then you simply find the number of electron gained or lost. From plus 2 to plus 2.5, change in oxidation state is 0.5 unit and number of such sulfurs are 4. So the total is 2, right? Yeah. From 0 to minus 1, the change in oxidation state is 1 into number of iodine is 2. So this is also 2. So electron lost and electron gained are already same. So no need of multiplying extra numbers with that. Okay. Now check the ionic charge. Here 2 into minus 2, that is minus 4. And the charge of iodine, that is 0. So in the left side, that is minus 4. And minus 2 here and 2 into minus 2 here. So this is also minus 4. Which means that there is nothing to balance in terms of charge. Okay. So charge is already balanced. And there is no hydrogen. So no need of balancing hydrogen itself. Or hydrogen again. So it is said that the reaction is balanced. Okay, moving to the next important case. That is, the next important case is the balancing in the case of hydrogen peroxide. Balancing the reaction in the case of hydrogen peroxide. In the case of hydrogen peroxide, the element that with the change in oxidation state will be oxygen. Okay. In the previous examples, we are not able to consider, we simply ignore the oxidation state of oxygen because it is not changing, right? But from here onwards, or in the case of hydrogen peroxide, one of the element with the change in oxidation state will be oxygen. Okay, let's check our reaction. Fe2 plus, that is ferrous ion, which is oxidized by hydrogen peroxide in let it be in basic medium. Okay, in basic medium, and so that Fe2 plus is oxidized to Fe3 plus. Okay, listen here. Here Fe2 plus is oxidized. Agreed? Yeah, Fe2 plus is oxidized. If Fe2 plus is oxidized, then if this species is oxidized, then the supporting H2O2 is an oxidizing agent. H2O2 which helps for the oxidation of Fe2 plus, right? So H2O2 is nothing but oxidizing agent. And this concept is discussed in the first part, right? Okay, so H2O2 is an oxidizing agent. Since H2O2 is an oxidizing agent, it becomes H2O. If H2O2 is an oxidizing agent, it becomes H2O. Ready? Ready? Okay, it is already discussed in the case of previous part, prediction of product. So this is a skeleton reaction. So please let me show it once again. H2 ferrous ion in presence of H2O2 forms ferrous plus H2O. So I told you that here one of the component, in case of hydrogen peroxide or any kind of peroxide, one of the component with change in oxidation state should be oxygen. Okay, don't forget that. Okay, so the element first of all you have to find the oxidation states. So iron is one of the element with the oxidation. What about the next? Oxygen here -1 and oxygen here -2. So oxygen is the next companion, or oxygen is the element which undergoes reduction. Okay. So iron with the oxidation, oxygen with the oxygen in H2O2 is the reduced one. So let's check the numbers are same. Here 1 Fe, here 1 Fe. Fine, that is okay. Here 2 oxygen, here only 1 oxygen, right? Yeah. So you multiply here with 2. Ready? Fine. And find the electron lost and gained. The change in oxidation state is 1 into number of atoms is 1. So electron lost is 1. Change in oxidation state is from -1 to -2, that is 1. But number of oxygen is 2. So electron gained is 2. So 2 electron gained, but 1 electron lost. So you multiply here with 2, right? Yeah. So that is okay. Electron gained and electron lost are balanced. Okay. Now simply check the charge. 2 into +2, that is +4. And the charge of H2O2, that will be 0. What about here? 2 into +3, that is +6. And the charge of H2O, this is not the charge of H2O. Okay, it is given by me. The charge of H2O, it is nothing but it is in the question, that is 0. So there is a +4 charge total of here and +6 charge total of here. And your medium is basic, right? Yeah. Okay. So you simply add 2 OH minus here. If 2 negative charges added to +6, it becomes +4, right? Yeah. So here 2 OH minus. Okay. Then charge is already balanced. Charge is balanced. Now let's check the whole charge. Sorry, a whole hydrogen. Here 2 hydrogen. Here we already have 4 and 2 here. So 6 hydrogens in this side and 2 hydrogen in this side. So you should add 4 hydrogens here in terms of 2H2O. Ready? Now the reaction will be balanced. Let's check it by counting the number of oxygen. 2 oxygen, 2 oxygen, 4 oxygen here, 2 oxygen, 2 oxygen, 4 oxygen here. Now the reaction is balanced. Okay. So moving to the next case. That is the case of more and more with the hydrogen peroxide, but hydrogen peroxide with the permanganate. So permanganate, let it be in acidic medium, it become H plus, sorry, Mn2 plus, and hydrogen peroxide become O2 because Permanganate is the oxidizing end and hydrogen peroxide will be the reducing end. If hydrogen peroxide is a reducing one, then its product will be O2. Okay. So this is a skeleton reaction. Let me write once again. MnO4 minus plus H2O2 gives H plus gives Mn2 plus O2. Ready. Now the elements with the change in oxidation state. There is first one manganese, and I told you that in case of hydrogen peroxide, oxygen will be one of the element. Here -1, here 0, and here we have +2. Ready? So simplifying the number of electron gained. Wait, before that, make the numbers are same. 1 manganese, 1 manganese. 2 oxygen, 2 oxygen. So the numbers is already same. So number of electron gained or lost. +7 to +2. 5. Okay. It is seen in most of time. Most of time it will be it is given as your permanganate, right? So in almost all examples, our main component is permanganate. Okay, so you are familiar with this. Okay, and -1 to 0, -1 to 0, that is 1 into number of oxygen, that is 2, so 2. Okay, so gained 5, lost 2, so you multiply with the 2 here and multiply 5 here. Check the case of charge. -2, H2 to the charge is 0, +4, O to the charge is 0. So +4 here, -2 here. And your medium is acidic, so you can add 6H plus here. And that 6H plus enters to here, then 10, 6, 16 hydrogen in the left side. The right side there is no hydrogen. So it will be 8H2O. Check the number of oxygen, 8, 10, 10, 8. So oxygen is okay, balanced. Now the reaction is balanced. Okay. And this is how the off-reaction methods are, oxidation methods are proceeding. Okay. Let me balance disproportionation reaction also.